Okay, data summarization. So now we're going to look at measures of center. So we're going to talk about the mean, the median, and then we're going to compare. So the mean, when we say mean, we mean average or expected value, specifically when we're looking at a quantitative variable. And typically the mean is going to equally weight every observation. So every observation is going to have the same weight to it. So if I had n observations, x1 is my first observation, x2 is my second, xn is my nth. So I'll add all of those values for my observations and then divide by the sample size. So things to note is if I have a symmetric distribution, the mean's going to be smack in the middle. But if I have a skewed distribution, the mean will be pulled towards the long tail. So if this were like the peak, the mean would be pulled towards that tail. The mean is absolutely, it's influenced by having extreme values on either end. Absolutely. The median is not impacted by having the extreme values on the end. It's the value that if you lined all of your values up in order, so ascending order, it's the value that's smack in the middle. So the median, it's the value that half of the values are above it, half the values are below it. It's also known as what, the 50th percentile or the second quartile. Nobody talks about it in terms of quartiles, but half of the values fall below it. So when we talk about the sample median, we'll denote it by this like X with a tilde above it, or just the capital letter M. It's not super consistent, not like X bar is for the mean. So things to note, if our sample size is odd, it's going to be the middle observation. If it's even, you're going to take the two middle observations and you're going to average them. So if I had a 1, 2, 3, 4, 5, these were my numbers here. I'm going to take the middle one, so 3. But if I had 1, 2, 3, 4, 5, 6, in order to get it in half, I would need to average 3 and 4. I'm going to get 3.5. So that's the idea. So for me, it's easier for me to put it in ascending order and then pretend to fold it in half. If there's only one value where you fold it in half, that's your median. If there's two, then you have to average them. So things to note, when it's symmetric, it's going to be smack in the middle, just like the mean. When it's skewed, I mean, it's not going to be pulled towards the tail like the mean is going to be, but it's going to be wherever it's located such that half are on one side and half are on the other. Just know that unlike the mean, it's not going to be strongly influenced by the outliers. So for example, we're throwing back to that weird engineering course, rigorous engineering course that has some sort of like entrance exam. And we want to go ahead and, for exam score, so it's telling us which variable to focus on, calculate the mean and the median. So for me, I'm just going to even rewrite these real quick. 78, 79, 87, 88, 92. So I was just rewriting them so they're in ascending order, so from smallest to biggest. If I want to find the median, so there's 5 of them, it's going to be the middle observation. So, hey, there's my median. So median is equal to 87. And it's an exam, so if you really want to put units, I'd put points. But for some reason, like with exams and IQ, there are a number of quantitative variables that we don't necessarily put units. But if it were something with units, you would want to include them here. So then my sample mean, so sample mean, sample. That's going to be, I'm going to now add all of them. So 79 plus, 68 plus 79 plus 87 plus 88 plus 92. So those 5 scores, and since there are 5 of them, I'm going to divide by 5. So if I do that, I get about 82.5 points. And so things to note for the mean and the median, it's okay if it's, a fraction or a decimal because it's an average. If it were just one individual person getting that, maybe not, totally depends. So that would be my mean and median. Whoops. Here's the info about the data set again. I wrote over it. No big deal. So comparing the mean and the median. So there are scenarios where, like, if you have a data set that is very symmetric, honestly, using either is totally fine. But if you don't have that scenario, you're going to want to be very careful about which one you use. So when you have data that are skewed, and just a side note, data are plural. Not that we're going to freak out at you, but I did have one professor totally flip out with a red pen every single time anybody wrote data is. Data are plural. Datum is singular. It's like bacterium and bacteria, except almost nobody ever thinks that. So when data are skewed or have outliers, so you have extreme values at one end, the mean's going to be influenced. It's going to be pulled this way. So one example I really like is to use is, suppose you're using Amazon employee pay, what people are salary. That's the word. But so you go ahead and you take a random sample from Amazon employees and you have their salaries. I'll tell you what, if Bezos, the owner, ends up in your sample, they are going to pull the mean so far above what it would be that maybe you don't want to look at the mean. Right? Absolutely. It would absolutely distort your view of what a typical value is. So just think about it. If you dropped a really high value, it would pull the mean towards it. If you, dropped in a very low value, suddenly it would pull the mean towards it. So you want to be very, very careful. If you have skewed data, the median is better. The median is not going to be impacted by one or two extreme values at all. However, if you have symmetric data, the mean or the median is good. So the median is always good. But when it's symmetric, the mean is also good. Things to note, the mean has a lot of really, really nice calc properties about it that we prefer it when we can use it. But the median will always work. So know that. Absolutely, when you look here, the mean and median annual income per capita for Seattle, we have 55,000 and some odd and 41.5. So there's definitely a big difference there. It does come from a skewed distribution. Income and salary almost always usually is very skewed distributions. They rarely are symmetric distributions. So keep that in mind. When people say, oh yeah, no, the average, pay at my company is blank. I'm like, cool, but what is the median income? Because the average often will be completely distorted when including people making a lot more money than other folks at the top. So lesson 19, now we're going to talk about variability. So here's where our center is. Well, how far, on average, does, the points vary from that value.